Hello, my name is Nick Balcom Raleigh, and I'm here with Professor for Solar Energy, Christian Breyer. He is the Professor of Solar Energy at La Parenta University. And recently, Christian has published made public a new model that shows how Finland can be 100% renewable by 2050. And I guess my first question for you is, when I see this headline on the press release, I think this is really great and poetic and amazing and feels like quite a radical change. It'd be very radical. But you say that it's actually not that radical. Why is that? Why are renewables not radical?
First of all, this 100% renewable energy scenario for Finland, it was one or a part of different scenarios. So in principle, we had a business as usual, everything focused on 2050. And business as usual showed it's the most risky scenario and slightly or on the upper end of the cost of all scenarios. The reason, of course, due to risk is we don't know, do we have stranded investments with nuclear? No one knows how this continues. And then, of course, then there are payments for CO2 emissions, and it's not really clear what is the level of the cost in 2050. So if it would be a really CO2 constrained world, then it would be really high cost. If we decide that maybe survival is not so important on the planet, then CO2 costs are not so high. But so this is rather on a high risk level, business as usual, and it's the most, how to say, negative scenario. The other scenarios, they mainly have a difference in what is the level of usage of nuclear. So is it a lot of nuclear, is it a kind of a moderate level of nuclear, low nuclear, or even no nuclear? And no nuclear is then a 100% renewable scenario. And for the special case of Finland, it's then a question how much biomass is used. So bioenergy, there's a lot of discussion on very high shares of bioenergy, bioeconomy. And due to that, the idea was, okay, we should have a lower limit and upper limit. So the lower limit is then really a sustainable limit, so only byproducts of other industries are used, whether it's from the forest industry, whether it's residues from the agricultural sector, municipal solid waste. So this is a kind of a very sustainable source, unfortunately. But this is then taken into account. And then to the key question, how radical 100% renewables are, it's then a question. So in other countries, it's discussed since many years. Denmark is a country there it was already discussed in parliament. The entire country agreed on it. It's now part of the legislation, and the country is already some years in the execution mode. So to that point of view, it's not really radical. And from the technological point of view, no major technological breakthroughs are needed. All technologies are known by today. Of course, there is a further development. They will be a bit more efficient. They will be a bit lower in cost. So this is ongoing development, but this is the same as it was for the last 10 or 20 years. This is nothing special. It's just continue on the road. And maybe the main radical thing is the mental thing. So just, it's possible. And I think the main contribution is now that there are different scenarios. And finally, from the cost, they're more or less comparable. So whether one scenario is lower in cost than the other, this is not a huge differentiator. But the key thing is finally 100% renewables is also a very good option for the country. And now the country can decide. Of course, in a democracy, citizens can and should now decide, and the rest, in particular, politicians should then execute what the citizens would like, whatever it is the decision of the citizens.
Sure. So, also in your model, you didn't just calculate for electricity, for the energy that we use as electricity. You also the model, the 100% renewable model, produces a great deal of excess energy, almost double. Correct me. But what is that for? What would the excess energy be used for beyond electricity?
Of course, in the entire energy system, excess energy is not really huge. But what we observe more and more is that due to efficiency reasons and cost reasons, more energy services and other energy sectors are finally based on electricity due to low cost and high efficiency. A good example is heat pump. Finally, electricity goes in, heat comes out, and whether it is then heating a building or whether it's used for district heating, it does not make a difference. But finally, heat is then delivered, but finally it's based on electricity. The same is with electric vehicles. So it's then the mobility sector, but electricity is used. And if one thinks that to the end and tries to calculate it, then it's quite obvious that finally the energy system is really mainly built on electricity, and the key reason it's low cost, because it's, for the case of Finland, it's mainly wind energy. It's also solar and hydropower, solar photovoltaics and hydropower will be more or less on the same level. It will be not a huge difference. And of course, for the special case of Finland, but this is really a speciality on the global scale, the share of bioenergy is rather high, so 30 to 40%. Most countries in the world, it's 5% or less. But the key reason is a rather large country for a rather low population, and then of course a lot of biomass for the population is available. This is then the reason, but except this bioenergy, the rest is mainly built on electricity, and due to that, in the entire energy system it's not excess, but of course electricity is more produced than what is used only for electricity purpose, what we would claim today as electricity demand.
Very good. So 2050 is chosen as the timeline for the model and also for the larger project of neocarbon. However, some of us may wonder, well, that's going to maybe help us with like hitting only going up 2 degrees Celsius by 2100. Is there any way to implement this sooner, and what would that take?
In principle, this is possible. First of all, the key thing is, okay, the reference is 2050, and why it's done 2050? First of all, many investments in the energy sector have a technical lifetime of 40 years. 20, 30, 40, 50 years, it depends which component, but roughly 40 years. We are now in the year 2015, so 2015 plus 35 is 2050, so it's roughly the time scale we have with our today's decision making and then ongoing decision making. For the next 35 years, this is the one point. And the other thing is, we know quite well from climate change studies that every emissions or all emissions in the energy sector by 2050 should be zero. And I think that's not really well understood what it really means, zero. Of course, we can easily talk on zero, but zero means there is no coal, there is no oil, there is no gas anymore. It's zero. Of course, there is gas, but no fossil gas. So in our model or in our scenarios, gas plays really a major role, but then it's synthetic gas. It's built on electricity used for electrolysis. Then we get hydrogen. The hydrogen is then brought into a reaction. It's called the so-called Sabatier process with for methanation. Small irony, finally CO2 is needed there. And CO2 and hydrogen as a reaction forms then methane, CH4, which is then called synthetic natural gas, which is from the chemical point of view the same as the natural gas we have today. So it's then a 100% substitute, but then it's built on a power-based renewable form. And of course then the question is, where is the CO2 from? So whenever we have then a kind of a sustainable CO2 source, which could be, for example, the forest industry, in Finland there were really good sources, but if that is exploited, this source, then we can take it out of air. Even that technologies exist today, and it does not cost the hell in energy. So in principle everything is there, but your key question was, can we build it faster? In principle, yes, but then of course tremendous more efforts would be needed. So I would be really surprised if one could come from a current status like it is currently for Finland, if it could come significantly faster than in 20 years on a 100% level. So I think 20 years is really the minimum, but more than 40 years is not needed. So this is then kind of not heading really ambitiously on the target if it would take longer. But everything within 20 and 40 years I think is possible, but it cannot build immediately, because compared to other industries, the technical lifetimes of most of these components are roughly 40 years, 30, 40 years. So it's not so easy. And then of course we would talk a lot of non-stranded investments, so investments done today, which would be then stranded. Of course, if today our investors also in Finland investing in coal technology, of course, then these investors should be not surprised if in 10 years this is a stranded investment. So I think we know which technologies are sustainable and which not, and everyone who invests in non-sustainable technologies should not complain in future. I think this is for sure.
And finally, I'd like to ask, how will your model be used?
Yeah, of course, first of all, the model, by the way, which we used there is not our own development. We used the model which was mainly taken in Denmark for the decision and finally for the decision making for the 100% renewable energy target. So by 2035 in Denmark it's 100% target in the electricity sector, and by 2050 for all energy sectors. And this model we have taken, it's freely available in the web, it can be downloaded. But of course a model is then so good as the input is.
Yes.
So it took us, I think, half a year to get all the good numbers together. There are, I'm not really sure, but I think 100 to 200 assumptions you have to take. And you have to take care on all of these parameters, that they're really well set. But we're very confident that the numbers are really good. So this is now there, and of course that it can be discussed. So it was very important, it's very important for us to do it in a very transparent way. So we have then several slides, several pages where most of the assumptions, or nearly all of the assumptions, are there. And then is the question, if someone is unhappy with a specific assumption, then let's discuss on it. So of course we know there are some assumptions, there are always discussions on them. There we have then more and more references on it available, but of course not everything will be perfect from all these assumptions, this is for sure. But our main idea is to have a contribution to the societal discourse, what should be the target for the country. And of course for that one needs first of all some results, what could be futures, what could be options to head for, and then of course one needs a list of information, and then based on all this data one can decide. So this is the key thing, but our next step will be then, of course it's only kind of a target for 2050, we have not elaborated how the pathway should look like. So this is now the next task we are heading on, is starting with today's configuration of the system, and then is the question, what are the different options of a pathway to reach the different targets. Of course on that basis one would then really say, okay, what does it cost for the next 5 years, and then for the next 5 year slides, what needs to be invested. And of course then it's easier to discuss what is the impact on the jobs, what is the impact on the trade balance, so then we would really better understand the pathway. This is then kind of a next step.
It sounds really terrific, and I thank you for your work on this as a citizen of the world, and also thank you for your time today.
Okay, thanks a lot, and of course I have to thank to the team who contributed to this work. So this cannot be done by a single person or 2 or 3 persons, so there is mainly, of course, a doctoral student, Michael Child, who did mainly the work, but then we had a lot of, how to say, advisors around us, so we had a special knowledge gap for a specific number, then you ask some people and finally you get the number, and then for the final work we had a kind of a review committee providing us a long list of comments, but of course this is then very helpful because then you get it on a better level, all this work. So then again, thanks of course also to all the people who helped to get it on a good level.
Indeed.